Students, welcome to India's most comprehensive online learning platform, BYJU'S Exam Prep. This is Anil Surampudi, and in this session, I'm going to give you people a perspective. I'm going to discuss about what should be the preparation strategy. Exactly when you are going to prepare for the concepts of COA. Let us understand something about the COA, that is, the computer architecture and organization is not as any other topic. This computer architecture and organization is a blended topic with every other topic. So in this session, I'm going to give you people what should be the preparation strategy, especially when you try to master these topics. So before we go any further, I just request you people to subscribe to the channel immediately. If you're already done, well and good. If you haven't done, just click on the bell icon. Before that, click on the subscribe button. So let us start. About myself, I'm a triple post-graduation holder. I did my master's in information technology. I did my master's in MBA. I also did my master's in mathematics from SV University. From the past 13 years, I'm in this field. I've been training the aspirants of the GATE all over India, across all places in India. Say it Delhi, say it Srinagar, say it the Kerala, it could be Andaman and Nicobar, everywhere in India, almost all parts of India, I've been teaching and I've been training the people for the GATE aspirants. I've been training the GATE aspirants. Now, hi, Anu, Ajay, good evening. Yeah, now let us get into the details of this computer architecture and organization. But before we go any further, let me take the initiative of congratulating all the GATE toppers from BYJU'S Exam Prep. I'm proud to admit that the BYJU'S Exam Prep, once again, it is proven that it is a pioneer and it is profound rank-making machine in every competitive exam. So in terms of GATE, I'm proud to admit that we bagged 41 ranks under AIR 50, 11 ranks under AIR 10, and 74 ranks under AIR 100. The rankers are Ram Balaji from EC, Vandit Patel from WE, and Parvinder from ME. Secured ranks 1, 2, and 3 respectively. I'm going to talk about the syllabus and the important topics when it comes to the computer architecture and organization from the GATE's perspective. In which topic, if you focus, you will be able to score good. I'm going to explain. Let us start with this. Now, when it comes to the weightage, let us take an analysis of previous any number of years. Then we conclude that, we will come to a conclusion that this computer architecture and organization topic will have the weightage in between, anywhere in between 9% to 12%. The score and the questions will be in between 9% to 12%. And when you look at the 2022 CS paper, it contains a total of 5 questions and, for 8 marks. And in 2021, we do have 4 questions in shift 1 and 5 questions in shift 2. In order to remind you again, in 2021, papers are having in 2 shifts. We did have our papers in 2 shifts. And the next thing is, in 2020, we did have altogether 11 questions in computer architecture and organization. So the weightage of the subject is anywhere in between 9% to 12%. Now let us talk about this important thing, first of all. That is, when you talk about what should be the preparation strategy when it comes to the computer architecture and organization, let me put it this. Before I discuss anything, let me put it this. Let me put it this way. That is, anybody who is, if he is a computer science student, most of the people, they say that the computer architecture and organization is one of the complex topics in the entire computer science. Let me tell you that the computer architecture and organization is not a difficult topic, is not a rocket science. We don't need to understand how the rocket flies. We don't need to understand what should be the fuel that is needed to be burned. We don't need to understand what must be the escape velocity. This computer science, in a computer architecture and organization, thanks to the way it is designed, it is a blend in every topic of the computer science. It is an integral part of every topic of the computer science. You take Java, this is an integral part. You take C++, this is an integral part. You take operating systems, this is an integral part. You take computer networks, your computer architecture and organization is considered to be an integral part. So, you avoid that perception. This is a misconception, misperception. The computer architecture and organization is one of the difficult topics in the world. No. Let me put it this way. How a complexity has been defined of any subject. Anu, tell me, how a complexity we are going to define? How we are going to say some subject is tough or easy? Simple. Simple. The thing is, we will open the book, looking at the paragraph, the length of the paragraph, we will close the book. That is the most complex subject in the world. If you feel that the length of the paragraph will decide the complexity of a topic, what kind of an engineer we people are? If the length of the paragraph, and when you talk about preparing for this, you need to think from the perspective of a designer. How to think from the perspective of a designer? Let me put it this way. Let us say I started the preparation of computer architecture and organization. So far, I don't know nothing about computer architecture and organization. Okay? And I'm good in programming. I'm good in C. I'm good in C++. I'm good in everything. But when it comes to the computer architecture and organization, I am zero. Before I start preparation, let me put it this way. I need to think from the perspective of a designer. That is, I need to think that I am the designer of the computer system. Then everything will be made very simple. So, before you start learning the computer architecture and organization, you need to think from the perspective of a designer. Otherwise, the topic will get complex. How to think from the perspective of a designer once again? Let us understand this. Here, let us say we are writing a program. Let us say the program is being executed. At least we need to know what are the necessary steps. Hi, Manikanta, Mamidi. Hi, hello. Yeah, we're talking about the preparation strategy of computer architecture and organization. I already told you guys that we need to think from the perspective of a designer. And again, when you talk about how to think, when you ask me how to think from the perspective of a designer, let us understand a few things very carefully. We are the programmers, right? Being a computer science guy, what we are expected to do? We expect to do hands-on coding. We are expected to do some good programming. I expect you people are the best programmers in the world. At least, we think that way. At least we are the average programmers. But being a programmer, what we are expected to do? We are expected to write the programs. The computer system is fundamentally a program execution machine. Now, when you execute any program, what exactly it is going to happen within the computer system, how the CPU will be able to get these instructions, where the programs are going to get stored. Sir, ECE के लिए आपको follow कर सकते हैं. Of course, for ECE also, we do have some topics of the computer architecture and organization. Definitely you can follow me, I will be helpful for you guys. Okay. Now, when it comes to the designer's perspective, we need to think from the perspective of a designer, and we need to understand how the system has been designed. Again, when you want to talk about the system design, we need to understand how the CPU has been designed, how the main memory has been designed, and how the peripheral systems are designed. Again, you don't need to get into the chip level design of the CPU. At least the design perspective is, we need to understand what is the function of the CPU. We need to understand what is the function of each and every entity of the CPU. What is the function of the register set? What is the function of ALU? And what is the function of the control unit? And everything we should be able to understand. You need to understand the design logic of the CPU rather directly designing the CPU at the chip level. You're not expected to do a chip level design. You're just needed to understand how all these components are integrated together to give you a program execution machine. How the memory is designed. From where to where the program is getting loaded. During the execution of the program, how the instruction by instruction access is happening. we need to understand at least these minimal things. These are not complicated, these are not complex, these are very simple. The moment you start listening to the classes, the moment you start understanding the concepts, you will be having a complete idea, complete picture that it is not and no more a complicated topic at all. Yeah. So first of all, we need to think from the perspective of a designer. We cannot think ourselves as an end user. If you think yourself as an end user, you will be an end user all the time. You can't be a system designer. You don't understand the computer architecture. Simple. Sir, please give some topics for preparing COA subject for PSC 3 exam. I will give you. I'll give you. Just follow this. The important topics in the session I'm going to cover are the important topics for any exam. So stay focused and understand. Yep, focus on the topics such as memory and the pipelining, where the maximum questions we are expecting in GATE. Of course, if you look at the history, if you told you that it is all about the design of the CPU, the design of the CPU comprises of several things. Initially, we are going to design the CPU. The CPU design will be covered in the register set design. CPU, just a minute, has been running. Yeah. The design of this, rather, the syllabus of the CPs, the syllabus of the COA is having these topics. Initially, we need to start designing of the CPU. In designing the CPU, we are going to, the total design of the CPU will be entirely covered in instruction set architecture. Right after which you need to design the memory, because memory is an important aspect of the computer architecture and organization, because the programs are going to get stored only in the main memory, and from the memory we are going to expect maximum questions. And then pipelining, what exactly is this pipelining? When it comes to the pipelining is a technique where the performance of the computers will get increased. What do you mean by performance? We are talking about the speed nowadays. Nowadays, we don't want a system which is a shutterwork. We don't want a system which is going to give you a lagging. Okay, so in order to avoid that, we need to have a better performance. So in order to have a better performance, one of the best adoptable technique is pipelining. Of course, in pipelining, we're going to get the maximum questions. If you look at the history, you know that you will understand that from the pipelining, we are getting more questions. And the IO organization design, of course, what is IO organization design? Sir, please give me, yeah, fine. What is IO organization design? When you have a computer system, you need to have a peripheral devices, all the peripheral devices, how they are getting connected to the computer system, to what interface we are going to connect the system, everything will be explained in the IO organization. When it comes to the computer arithmetic talks about what are the data formats supported by the computer system and how the ALU is going to perform the operations and all such things. Now, let us get into more details of the syllabus. Yeah. In the instruction set architecture, we majorly talk about the CPU design. CPU design comprises of several things. The first thing is the register set design. In the CPU, we do have three major entities. First thing is the register set, will be covered in the register set design. Second thing is the ALU, will get covered in the ALU design. And the third thing is the control unit design, will get covered in, Third thing is control unit design, will get covered in a control unit design, with the subtopics like how the instruction get executed, during the instruction execution, what will be the phases that it is going to go through, and what are the different instruction formats, how an instruction is going to be designed, and what are the different kinds of instruction that are available within a system that are going to be discussed in instruction set completeness. And we are going to take one case study of RISC architecture. In RISC architecture, we will understand all these techniques, by taking the RISC architecture, we are going to understand all these design aspects, because every time when we try to design something, we need to have a case study. Through that case study, we are going to understand what are different techniques, what are the different topics that are incorporated and implemented within a computer system. Yeah, when it comes to the memory, let me tell you, this is an important topic. Once again, let me admit that this is the important topic no matter which exam you are preparing for. From the memory, you are going to expect a maximum questions because this is a huge topic. Okay, and in the memory, we are going to understand how the addresses are generated, how the addresses are created, how the memory address will get mapped. Right after which, we are going to understand how the cache memory is designed, what is the purpose of the cache memory, and when an address has been generated, how this address is going to be mapped and located within the cache memory, what are the different strategies for cache memory address mapping, such as direct address mapping, set associative address mapping, and associative address mapping. We are going to discuss everything which is related to cache. Once again, within the memory, the cache memory is furthermore, moreover, is an important topic. Okay, within the main memory, you're going to expect more questions on cache. Say it could be NAT question or any other question. You're going to expect maximum questions from the memory, that too from the cache. Okay, the topic cache. And we're going to understand what are the different misses and types, and also we're going to understand the virtual memory. Here, I want to put something with the virtual memory. What exactly is this virtual memory? Virtual memory, we're going to discuss about all the whereabouts of the virtual memory. But here at this point, I want to make it clear that this virtual memory, if you learn, you are going to be benefited in two ways. That is, this virtual memory is an intersecting concept for two topics. One is computer architecture and organization, and the second one is operating systems. So, in two ways, you will get benefited. These topics, as it is getting covered in two different ones, one is computer architecture and organization as well as operating system, you may be able to solve any question from any subject. Yes, of course, illusion of the main memory, but I'm not getting into the details of the virtual memory. Rather, we will just confine ourselves to the discussion of how to approach for each and every topic. And the next one is a logical memory. If you extend this virtual memory topic, you will arrive to a conclusion that we will end up this virtual memory topic at a logical memory. And finally, we are also going to discuss about how the memory is going to be protected from unwanted usage. You do have a lot of programs in the main memory. Each and every program must be protected from unauthorized accesses. How the memory is going to follow the steps, how the memory management is going to protect each and every address space of each and every program. We're going to learn in memory protection. Once again, this is an important topic. Entire memory is considered to be an important topic from the perspective of GATE or any other competitive exam, because it's a huge topic. That too, focus on cache memory. Yeah. Next, talk about the pipelining. As I already told you, the pipelining is a technique to improve the performance. Now, what do we mean by performance? This performance improving is a regular process. We can't get satisfied. Today, I'm having i9 processor. Tomorrow, I may have some other processor. Yeah, by use of the base and limit registers, of course, I know that. But still, base and limit registers will just tell you what is the origin and destination, rather what is the, and exactly from which location to which location a program is placed. But whenever some other program is accessing this program, how to avoid that, we're going to understand in the memory protection. Of course, base and limit registers will be the origin in the memory protection. A very good answer that. Okay, that is a very good answer. Now, when it comes to the pipelining, as I state that, this performance improving is a regular process. Computer system is always in an evolution period. Right from the day it is invented, at the time 2020 to April, still it is in the evolution period. We are starving for more better and better performance. One very good technique for having a better performance is pipelining. When you implement pipelining, you will have a very good performance, especially when you compare it with when a non-pipeline system in between a non-pipeline system and a pipeline system, you're going to understand what exactly is the performance, how exactly is the performance is getting improved, what is the performance gain, everything you're going to understand. But for that, we need to understand what are the different pipelining techniques, what are the different pipelining strategies. There are several pipelining strategies. The first pipeline is the data pipeline. Second one is the instruction pipeline. How this data pipeline and instruction pipeline together improve the performance. What is the speed up ratio? How and what is the speed up ratio that is being gained when you especially compare it with a corresponding non-pipeline system? We're going to understand in the pipeline. One more thing is, when you start thinking about the pipelining, let us say you're designing the pipelining. But when we design anything, even if we design a table, there will be a lot of complexities. We need to go through a lot of hurdles. We need to face a lot of difficulties. And that too, we are defining and designing a system which is going to improve the performance of the CPU. How profound it must be. Of course, we are going to face a lot of difficulties. That we are going to discuss in the pipelining hazards. Pipelining hazards will tell you what are the difficulties that we may face during the pipeline design and how to provide the solution for each difficulty. We're going to discuss in the pipelining hazards, right after which we are also going to understand some illustrative examples through which we are going to masterize the concept of pipelining. Yeah, next thing is I/O organization. How I/O devices will be able to get connected to the CPU, and in which we're going to understand what are the different transfers, from where to where the information will get transferred, what are the different locations where the information will get exchanged, from the I/O device to the main memory, how the information will get transferred, what are the modes of transfer, everything we'll discuss. In addition to which, we also going to discuss about some I/O interface. We need to have an interface in order to communicate, in order to establish a communication medium in between, the CPU and the I/O devices. Yeah, hazards and hurdles of the pipeline. Of course, it was related to the pipelining concepts. So here, when it comes to the I/O organization, we will design a simple I/O interface, after which we will understand the asynchronous data transfers. When you talk about the data transfers, data transfer will be divided into two things. One is synchronous and asynchronous. What is the difference between synchronous and asynchronous transfers? What are the various asynchronous transfers we are going to understand? And after which, we are going to understand one important concept, that is modes of transfers. That too, within the modes of transfers, there is one more important topic. Mind you, to recall, in one of the previous slides, I explained that virtual memory is an intersecting topic in between COA and operating systems. One more intersecting topic in between computer architecture and operating system is interrupts. So, if you learn interrupts, you will be able to answer any question from the COA, you will be able to answer any question from the operating systems, especially when it comes to the interrupts concept. And one more thing is, if you masterize this interrupt concept, you will have a better picture on the computer system. Not only the interrupts, if you actually can understand how the interrupts are going to be generated, what are the different interrupts that are going to be accepted by the system, how each interrupt is going to be serviced, you're going to get a clear picture how the computer system functions. So, focus on the interrupts and do not miss these interrupt classes and stay focused. And the next thing is, we are also going to discuss about the direct memory access, and we will understand the design of the IOP, input and output processor. We will design the input and output processor, right after which we will understand about the serial communication. The next thing that we're going to discuss is the computer arithmetic. The computer arithmetic is relatively a simple topic. Here, we're just going to discuss about the various data types and the data formats that are going to be supported by the computer system. Not only the data types and data formats, especially when it comes to the computer architecture and organization, we are going to emphasize on the errors. What is an error and how an error is going to be detected, how an error is going to be corrected, everything we're going to discuss in the computer arithmetic. Here, to put it simply, what is an error? If 1 transmits to 0, rather, if 1 gets transferred to 0 or 0 gets transferred to error in a different way. I'll put it in a simple way. You're transmitting one message, 101, from one end to another end. Okay. When you transmit a data 101 from a starting point, even at the ending point, you should be able to receive 101. Otherwise, what will happen? There will be error. If you do not receive 101, we need to understand that there is an error. The error can be triggered from too many sources. Let us say you are working with a computer system and you switched on your mixer grinder. There might be an error because how the data is going to be transmitted, on what medium. There are some tiny lines. On the tiny lines, data tend to get transmitted. Data will get transmitted. During this data transmission, a simple external disturbance can change 0 to 1 and 1 to 0. If 0 is unnecessarily changed to 1, that is an error. But we cannot afford the errors. If there is an error, we must be able to track that error. We must be able to identify that error, after which we must be able to rectify that error. how the errors can be detected, how the errors can be rectified, we'll be able to understand in the computer arithmetic. And when it comes to the operations that are going to be performed by the ALU, of course, addition and subtraction can be easily performed, but how to perform multiplication and division? Because there is nothing as such multiplication, there is nothing as such division. Multiplication is a loop of additions, division is a loop of subtractions. But ALU don't know what is a loop of addition, ALU don't know what is a loop of subtraction. Through some algorithms, we should be able to implement these multiplications and divisions. We will understand about the multiplication algorithms and division algorithms, right after which we will have a complete picture on computer architecture and organization. When we summarize this, when we look back from this point to the instruction set architecture, we will have a complete idea on the system that's been designed. Here, once again, we are not looking at the system from an end user's perspective. We are looking at the system from a designer's point of view. So, mind you, we design the instruction set. At this point, we designed the memory, we designed the pipelining. At least we understood the design logic behind the instruction set, behind the CPU, behind the memory, behind the pipelining, behind the IO organization, and behind the data formats that are going to be supported. So now we are going to have a comprehensive idea right after we finish each and everything. The concept that are needed to be watched is memory, pipelining, and that too in the memory, cache memory. In the pipelining, several techniques of the pipelining, speed up ratio and all those things. And in the memory, once again, virtual memory. And when it comes to the other topics, one more important topic which is going to intersect in between computer architecture and organization and operating system is interrupts. So virtual memory and interrupts, we must focus more, because this concept, if we actually can masterize, will be benefited in two ways. I hope you got it. So what are the reference books? The reference books must be the first one. Let me put it this way. What should be the Holy Bible for the computer architecture and organization? The Holy Bible for computer architecture and organization is Computer System Architecture by Maurice Mano. You need to have, no matter what it is, it could be a physical copy or an online copy. It can be a software version. You just need to keep this copy with you all the time. It should be your Holy Bible. Don't watch that. Don't read that. I'm not asking you to go through the complete book. Just keep it with you. Every time when you have a doubt during the session, you just need to refer that. And another one is Computer Organization by Carl Hamaker. In addition to the material that is being provided by the BYJU'S Exam Prep, you need to have these two books. So what should be your first reference when it comes to the computer architecture and organization? Your first reference must be, every time when you do have a doubt, what you need to consider. The first consideration, the thing that you need to consider is, how you're going to clarify the doubt is through myself. Initially, the first preference to solve any doubt must be myself, Anil Sorumpudi, right after which you go for all these books. Okay, in addition to the notes and the material that is being provided by BYJU'S Exam Prep. So with this, this is my Telegram link. You just can join. I also will send my Telegram link through the messages. So please subscribe, and not subscribe, please join in my Telegram group so that you will get updated. So stay tuned and subscribe to the channel. If you have already done, well and good. If you haven't, please click on the subscribe button as well as the bell icon. So stay updated and stay informed with every update. That's it from my side. Anil Sorumpudi signing off. Thank you so much.